Alright, this is our first video. This video is about safety in science. Specifically, we're going to talk about two things. The first one is understanding chemical hazard labels, and the second thing is MSDS, Material Safety Data Sheets. So we're going to start by looking at a chemical hazard label. You should have, by the way, your Understanding Chemical Hazard Labels and MSDS worksheet, so you can fill that out as we go. It's sort of like taking notes over our video here. Besides this video, you should also have shared with you in Google Classroom, you should have two other resources. One of them is an MSDS for the chemical acetone, which is the stuff that makes fingernail polish remover smell. It's the really strong smelling stuff in fingernail polish remover. The other thing is a information sheet about how to read a chemical label, how we interpret the code that the label is telling us about. So those two resources might also help you. We're going to go through really quickly, hopefully here, a description of both of these things, chemical labels and MSDS. First, a chemical label. The chemical label in this picture is the diamond, just a diamond, on the right-hand side of the page. That would be this thing right here, with the red, the blue, the yellow, and the white smaller diamonds inside of it. So those are that's the hazard code label. The name of this particular chemical that it's coding for is diborane. Diborane is just, I don't really know what they use it for, but it's a very dangerous chemical. I only know that because I'm looking at the ratings. We see the four colors there, red, blue, yellow, and white. Each of those represents a particular type of hazard. We see that where it says example. Blue is health, red is fire, yellow is reactivity. That means if you mix it with certain other chemicals, it's likely to react probably explosively. The higher the rating, the more explosive or dangerous the reaction can be. And the last rating, the white one, is a special type of hazard. It's handled a little bit differently. We'll talk about that. Underneath our label, you see the rating system that's used. We see 0 to 4 is our scale. 0 means minimal, like pretty much no hazard whatsoever. 4 means it's a severe hazard. We'll get into a little bit more detail coming up with that, but for now, just know we go from 0 as the lowest, 4 is the highest. For diborane, we see the fire hazard is a 4 because it's got a 4 on the red diamond. Very, very severely flammable. 4 for blue, that means it's very bad for your health if you come in contact with it. I'm not sure exactly what it does necessarily, but it means it can kill you. I don't know if it burns you or poisons you or what, but it will definitely be able to kill you. That's why it's got a 4 rating. A 3 for reactivity means it is a serious reactivity hazard. And the last one, again, which is a little bit different, there's not a number here. The last one is a special hazard. It's going to list anything unique about that particular chemical, unique and dangerous. In this case, it's got a W with a slash, which means don't get it near water. W stands for water in this case. That slash there, it means do not get it near water. It will ignite spontaneously, even in moist air, like if it's really foggy out. This stuff could ignite just because it's got a high humidity. It doesn't need to be in the water. So that's diborane for an example. If I was looking at that acetone label, the acetone MSDS, I would get different numbers. I wouldn't see a 4, a 4, a 3, and that W. It would be something completely different because each chemical has its own set of ratings based on its characteristics. So diborane, pretty nasty stuff. Acetone, pretty nasty in some ways, but nowhere near as bad as this stuff. Alright, so let's go forward here. First, we have a question. This is just, again, a review of that first slide. The NFPA hazard code label indicates 4 types of possible hazards for a chemical. Which one is not a category found on that label? Health, reactivity, fire, storage, or special. If you can't remember which one it is, go back, listen again, go back to one of those resources and look it up. You should know this before going forward. We'll talk about this on Thursday. Alright, so next up, this one is what number indicates the highest hazard rating a chemical can get. Once again, this is something you should remember. We just talked about it. If you don't know what the highest rating is, and for that matter also what the lowest rating is, go back, listen again, go back, read about it on that chemical label resource that I shared with you. make sure you know it before you get too much further here. Make sure you know what those numbers are so we know what these labels mean. Alright, going forward here, we have some more details about each section. We are not going to go through all this, but you feel free to pause and read through some of these details on how numbers get their ratings. Very much like a rubric in class, we've got a 4, 3, 2, 1, 0 scale. Depending on the characteristics of that material, it's going to get a different rating. So you can see what would make diborane have a 4 there. You can see what would make it have something that could have a 2, or something would be a 1. You can see what would give each rating. So there's blue and red, health and fire. And we also have yellow for reactivity. And remember, white is the unique one with special hazards. We see again for the white, ox for oxidizer, acid that represents acid. Alk, A-L-K, stands for alkali. Alkali is kind of the opposite of an acid. Both are dangerous, both extremes, acid or base or alkali. Those are both dangerous. COR is for corrosive. We already saw the one about don't use water. And the last one, which is kind of covered up by the Screencast-O-Matic logo down there, is a radioactivity symbol. It means it's radioactive. If we had some radioactive stuff, that's the symbol we put on there for the special diamond, the white diamond. Alright, so each section of the hazard code label should have a number in it except which one. One of them has something different about it. You should know this one as well. So, I'm going to move on here. Next up, you should, hopefully, remember which one of these goes in which part. We got 4 colors, red, yellow, blue, and white. I'm actually going to make this happen here, so you should try to predict which one goes where and see if you got it right. So I'm going to fill these things in with the colors in the right direction. Remember, these always go in this direction, so red will always be on top. So if this was in black and white, you couldn't really tell. You should still be able to know the top one, the red one, is flammable, the flammability. The blue one on the left is health. The right one is always going to be reactivity, and the bottom one is always going to be white for special. We also have, over to the left, we have health rating, flammability rating, reactivity rating, and a special says none. So we're going to fill that in with some numbers. Because we know red is flammability, that's where the 3 must go. Health is a 1, reactivity is a 0, and there is nothing for the special hazard. So we don't put anything in there. So for this particular chemical, whatever it might be, it doesn't look very much like diborane because it's not. It's not diborane this time. It's got a flammability hazard of 3, which is pretty serious. But the health hazard is only a 1. The reactivity is 0, meaning it's not going to react explosively with other stuff. And the special category gets nothing. There's nothing dangerous to worry about. No special things to worry about. You don't have to keep it away from water. It's not going to corrode through metal. None of those special considerations need to be concerned with this material. Pretty much just flammability is the only one that's really serious here. So let's clean this up. We're going to go back and start this over. And let's go on to the next thing here. The next part of this is MSDS. MSDS stands for Material Safety Data Sheet. Just like it sounds, an MSDS is a data or information sheet that helps you stay safe when working with materials, in other words, chemicals. The information found on MSDS includes, this isn't everything, but this is a pretty good list of the kind of things you can expect to find. The name of the stuff, dangers, what kind of dangers do we see when we're trying to work with it, what should we be aware of. Physical and chemical characteristics, in other words, we call those properties. Characteristics that the substances have. That means like, does it have a particular color, or particular smell, or does it react certain ways? Does it have a certain density? Things like that. PPE, personal protective equipment. That would be like gloves, goggles, aprons. a respirator mask? What kind of things do we need when we're using this stuff to stay safe? What do we do in an emergency? What do we do in case of a leak or spill? Always stuff about safety. That's why it's called a material safety data sheet. Any place chemicals are kept or used, there needs to be a booklet with the MSDSs for those chemicals in it. There's an MSDS booklet in our classroom. I'll show you that on Thursday when we talk about this stuff. There's also one in every other science classroom. There's one in the custodian's office. There's one at Lowe's in the paint department. There's one anywhere they sell cleaning supplies or other chemicals. Pretty much every store ends up having these because they always have at least some cleaning supplies that the custodians at that store are going to use. So that everybody has to have one. The reason is you have a right to know. People have a right to know what kinds of hazards are associated with the chemicals that they're using, especially an employee who has to use that stuff every day. They have a right to know what kind of dangers there are associated with that stuff. So that's where you're going to see MSDS books all over the place because of that. Which of the following would you not expect to find in an MSDS sheet? The price, any reactions a chemical undergoes, what to do if there's a fire, and what to do if there's a spill. One of those things is not like the others. And our last page is an example of an MSDS. This is for isopropyl alcohol. That's, in other words, that's called rubbing alcohol. That's the stuff that you would put on before you get a shot. You'd rub it on your skin. The stuff you put on like a wound to make sure you get it clean. That's rubbing alcohol. Isopropyl. This is only part of the MSDS. You can see, though, just by looking at this part of it, that this document is divided into a bunch of sections. You can see 4 of those sections here. Really, there's going to be more like 15 sections by the time you're all the way done with this, because, again, it covers lots and lots of information. We will talk more about the MSDS for acetone on Thursday. Please make sure you have the worksheet done for Thursday. If you need to use the other resources that I share with you, please do that and bring this back with you, and we will talk more about this stuff then. Thanks.